Hey folks, Doug Blake with Body Design University. Welcome to another weekly study. And in today's video, what we're going to do is talk about concentric and eccentric contractions. Now, just keep in mind, this is coming from chapter 7. And I got my trusty textbook in front of me. And if you have yours, you're more than welcome to open it up. And chapter 7 is a bear. As some of you already know, chapter 7 is a little bit challenging. It's on the human movement system or human movement science, and there's a ton of terminology in it. And I know that there's many of you out there that just struggle with trying to memorize terms. So just so you understand, we're going to talk about specifically trying to understand concentric and eccentric contractions in particular, but just as a little pre-intro, just keep in mind, chapter 7, yes, with all of the terminology and vocabulary, keep in mind, NASM has given you, obviously, on the sidebars, all the pertinent words, phrases that you do need to know. I'm not saying they're going to ask a lot of these as questions on the exam. They normally don't. That's just not their MO. They're not going to ask you to define a term. It doesn't make any sense from a knowledge-based standpoint anyway, but they'll use them in conditional type of questions or other questions where they might have them as a possible point within the response, something like that. So not a bad idea just to go through your read, write, recite methodology. Remember, when I say read, write, recite, what I'm saying is that you read the information, but reading is not studying. Remember that. Say it over and over until I'm blue in the face. Reading is not studying. It is the beginning of studying, especially with heavy science-based terminology. I like to use writing paraphernalia that allows me to draw in different colors. So the read part of it, yes, you've got to read, but the writing can be just a written word, right? Use a pen or pencil. And sometimes for some folks, it's easy to memorize terms definition just by write and rewriting it over and over, and it sticks in your brain. Other folks, and if you're a visual learner, here's one of the little tips or tricks, is visual learners are not people that read and learn. Okay, that's not how it works. Visual means that your brain functions in a way that is more suited towards colors, shapes, forms, things like that you can look at. And that's what allows for connections to be made between the material and your short and midterm and then ultimately long-term memory bank. So colors, okay, drawing things, that's the visual learner, somebody that you can watch things, but again, just watching a video is not how you memorize. If you watch a video, if you find yourself going to like our channel here and you're watching me just as a for instance, but if you find that you like to go in and watch the videos of the muscle shortening and lengthening, absolutely. But stop it, pause it, and draw it. And do something that's going to help you engage what you saw on a piece of paper in some way, shape, or form. That's the tip. That is sort of the trick if you want to know how to do it from a visual learning perspective. Audiologically, you still have to read. Audiological learners still, when they're listening, the connection is a lot easier. But again, stop the audio, whatever you're listening to, and try and rewrite what it is you just heard. Try and visualize it in your brain and see if you can write it out. Sometimes that is the connection you need. And of course, the kinesthetic learner, what they call the hands-on learning, that's not what it means. It doesn't mean that you've got to physically be doing stuff. It means that you have to distract the physical. You've got to distract your tactile senses. So the tactile kinesthetic learner has to have their tactile senses distracted so you can do other things. Now, it doesn't mean that, it doesn't help for you to sit there and do this. Go, okay, flexion, extension. Oh, that makes sense. Sure, there is that to it. But what we talk about with kinesthetic learners is that you need to hold on to a squeezy ball or something that distracts the kinesthetic component, right? What you're doing, so you can now focus on reading and rewriting. So we'll have students literally using these little rubber squeezy balls and just holding on to them. That's what that widget thing that kids use nowadays is designed for, to distract but it's better to use a ball where it's just, if I'm a lefty, I'm right in here, got the ball, and that just acts as a distractor so that I'm not constantly doing this all the time. How many of you are like that, right? It distracts you. Now you can focus on the task at hand, which is to read it. And you'll notice I've got my hand, I'm not holding the ball, but if I had one, okay, so there's my mouse, right? So if I'm holding it, that textural element to the squeezy balls allows me to then focus on what I'm writing and rewriting. So there's your intro to the intro. So chapter 7, as I said, is a lot to it. And within chapter 7, of course, are your muscle actions. And that's what we're going to talk about today. Many a student gets confused. Again, it's understandable because there's this three-dimensional visual element to muscle actions that can be a little bit confusing if you're not working and you're not training yourself and you haven't been working out for any length of time. But anytime you look at this material, this information, it's going to be helpful to know a couple of terms. And that's what I want to do today in this video, is kind of give you a little bit of assistance and help. For instance, to make you go, oh, I get it. Aha, got it now. That makes more sense. Lengthening, shortening. That's what I want to do. And I'm going to pull up our presentation here and help you out with some concentric and eccentric contractions. Now, I know what you're asking. What about isometric? Yeah, if you want to throw that in there, that's fine. Remember, isometric. Iso is same, Latin for same. Metric system is a length-based system. So isometric means same length. Remember an isosceles triangle, same length, same sides of the same length. And so isometric contraction simply means when the muscle is under tension, but it's not shortening or lengthening. That is reserved for these two guys. So the first one is the concentric muscle. And let's go back to basics. So we've got all the bases covered here. What is a concentric contraction? It's what we call the positive. If you're in the gym working out and you're doing a dumbbell curl and you lift the dumbbell up, the muscle is shortening, right? In order for the muscle to shorten, it's going to produce what's known as flexion, right? So the concentric or the positive is when the muscle shortens. The muscle literally goes from one length and goes to another length that is shorter than the original length. And when it does that, it pulls on whatever bone it's attached to, right? The eccentric or the negative is the exact opposite. That's why in most cases, these terms are easy to remember because you've got two terms. You just got to remember one is the exact opposite of the other. The eccentric, or what's known as the negative contraction, is when the muscle lengthens. So if a muscle shortens, it's going to lengthen, okay? Remember, muscles only pull. So the tension that is developed when a concentric contraction is enabled generally moves the limb a certain way. Now, that muscle that just shortened is going to have to lengthen. But the way it normally works is that the way that muscle lengthens, right, in the case of a dumbbell curl, is that the resistance now is being controlled as the muscle lengthens through the eccentric contraction. And there's also the antagonistic muscle that can contract to do it. But the concentric contraction, if you think about it, and I like very simple pictures. And that's what these guys are. Very simple, very easy to understand. If you look, excuse me, if you look at the length of this muscle over here versus the length of that muscle over here, what do you notice? Well, this length is longer than this length, okay? So a concentric contraction is when a muscle belly, right, goes from one length and then shortens to another length. That's called a concentric contraction. Okay, so we go from picture number 1 to picture number 2. Okay, muscle belly goes from this length, as you can see right here, that length right there, and it shortens to this length. Okay, it's called the concentric contraction. There it is. Now, it's just the opposite when it goes from this length. Now, remember, though, this has to be tension. There has to be tension generated. And that's normally going to come from just the weight of the forearm. In this case, it's the bicep, or a dumbbell doing a dumbbell curl. Okay, as long as there is tension developed and the muscle is shortening under tension, it is technically a contraction, a concentric contraction. The opposite occurs when the muscle lengthens, and that opposite movement is the eccentric. So when you're lowering, you're holding a 20-pound dumbbell, and as you lower it, the bicep, for instance, is still under tension, but the muscle now is lengthening. And so the muscle is essentially controlling, right? The lengthening, right? The muscle is controlling as it lengthens, it controls the movement of that resistance back down to this original length, which is right here. So I hope that makes sense. It's pretty straightforward, concentric and eccentric. Now, and of course, an isometric is any position where there's no movement. So technically, that is an isometric contraction. When you hold a dumbbell here, or you hold a dumbbell here, or you hold a dumbbell down here, as long as there's no movement of the muscle itself, that's an isometric contraction. So that's why that is pretty straightforward. We're not going over that. However, here's where it gets muddy. It's these two terms known as flexion and extension. Okay. Now, I just want you to keep in mind that when we talk about concentric, eccentric, isometric contractions, that is the muscle. That's the muscle. That's the soft tissue. That's the activity of the muscle. However, when we're talking about the concept of kinesiology and human movement, just talking about a muscle doesn't really help us. It doesn't get us to the finish line. We have to actually talk about what those muscles do at the particular joints. And that's why NASM, for instance, gives you an appendix C. If you go back there in your textbook, it shows you pretty much all the major muscles and what their concentric, eccentric, and isometric actions are. Okay, now, and I'll get to this in 1 second. Flexion and extension. Now, again, there's any number of terms in that chapter, but flexion and extension are two basic kinesiological functions that occur in the sagittal plane, right? So flexion and extension are the two terms I want to talk about here because, in particular, students ask about certain muscles, and we're going to focus on the hamstring because that was one student actually asked about the hamstring itself. And so that's why I'm going to focus on that. But any of the kinesiological terms like abduction, adduction, dorsiflexion, plantar flexion, doesn't matter. The concept of flexion, extension, and any of those other kinesiological terms moves from the muscle to the joint. Okay. I get this all the time. The confusion is understandable. The terms can be confusing. See, if you look at the term flexion, flexion has nothing to do with muscle. But what do we talk about when we do this, when we go like this, when we make a muscle? We are flexing our bicep. What does somebody tell you to do when you get to the top of a dumbbell curl? Flex your, see, because that term flexing your muscle is so close to the term flexion, we get confused. We think this term flexion means something about the muscle. It has nothing to do with muscles. Nothing. This is all about arthrokinematics and other elements related to kinesiology. Okay, and in kinesiology, we use these type of terms: flexion, extension, abduction, adduction. So that's why I wanted to go over this, because I know that there are many folks out there that look and go, I'm confused because it says flexion, but the muscle is lengthening and it can be confusing. So I want to make sure we separate those terms. When you see the term flexion, extension, abduction, anything like that, when you see those terms, it's always going to be about the joint itself. Forget the muscle. Just imagine you're looking at a skeleton. Imagine you're looking at hope you all can see this, my two pens. It's the joints. It has nothing to do with the muscles. Muscles, when we talk about the muscles and what they do, we're talking about contractions, concentric, eccentric, isometric. But as soon as you get into the world of kinesiology, for the most part, just the terminology, you could be talking about two sticks. It's joints, but I'm just saying it's segments, right? Flexion and extension. Do not get confused with flexion, meaning flexing the muscle and creating a concentric contraction. It has nothing to do with that. Okay, please understand. This is can be very confusing Because if you think that flexion means flexing a muscle, then you're going to miss the fact that flexion of the triceps creates extension at the elbow. Let me say that again. If you confuse this and you think that flexion, or you confuse the term flexion with the flexing or the concentric contraction of a muscle, you're going to lose, right? Flexion itself. You're going to lose, the understanding that when the tricep flexes, okay, when it flexes and goes through a concentric contraction, it actually extends the elbow. So we don't want to get confused with that. So always keep in mind, and I'm just kind of using you've seen these pictures from the NASM textbook itself. Basically, in chapter 7, they give you the different kinesiological terms and movement patterns, of course, flexion and extension. Opposite, right? They're just the complete opposite. Remember the definition of flexion and extension. If you think about this, you're not going to get confused with any of these muscles when you read through and you see the hamstring complex or the quadriceps or the calf, whatever the muscle is. When you've got to understand that we're talking about the muscles contract through concentric and eccentric, but what they do is kinesiologically flexion or extension, abduction and adduction. I hope that makes sense. So in this case, and I drew hip flexion and extension, and of course knee flexion and extension, so that we can kind of get an idea of the hamstring in this case. And if you look at page 861 on the hamstring complex, biceps, femoris, long head, short head, NASM gives you probably a little bit more information than you actually need. The idea that a concentric function is to concentrically accelerate knee flexion. Here's what I recommend you do, just for your own sanity. Take those first two words out. Where it says concentric function, concentrically, just take the words concentrically accelerates out. The kinesiological function of the hamstrings is knee flexion and hip extension. You don't need this acceleration, deceleration stuff. It's not necessary. It's way beyond what anybody needs in a personal training scenario. It's more confusing than anything else. It doesn't have to necessarily accelerate or decelerate knee flexion. Acceleration is a vector term. It's velocity over time. Deceleration is the same thing. So technically, it's not necessary. I'm not saying it's incorrect, just saying it's not necessary. And again, for your own sanity, do yourself a favor. Take out those two first terms, concentrically accelerates, eccentrically decelerates. No. The kinesiological function of the hamstring is to flex the knee and extend the hip. Now, just keep in mind, the exact opposite occurs in the eccentric contraction. So if the concentric function of the hamstring is to flex the knee, when the hamstring is under eccentric contraction, what does it do? It allows for knee extension. I hope that makes sense. Knee flexion, right? Where the angle, see what I said? The angle between two bones or body segments decreases. Extension is the angle between two bones or body segments increases. So if you look at the angle, right now between the upper leg and the lower leg at the knee, what is that angle? It's about 180 degrees, right? Because the leg is straight. The angle, the angle between two bones or body segments decreases. Now take a look at the angle between the upper leg and the lower leg. It's about 90 degrees there. To go from 180 degrees to 90 degrees means that the angle decreased. That is called knee flexion. When it goes from 90 degrees with the foot up here, back down to this position, that's what we call extension, when the angle between two bones or body segments increases. Now, if you look at it as this, the same thing occurs at the hip. The hip, this is going to be the hip joint. So upper body segment, lower body segment, lower body segment. What's the angle? What's this angle right here? 180 degrees, right? Okay. Now you move the leg up. You move the leg up to this position, right? What's the angle now? So you got the leg and the upper body segment. What's that angle? It's about 90 degrees, something like that. What happened? The angle decreased. Therefore, it is kinesiologically, the kinesiological term we use for that movement is flexion. If we move it back down this way, that's called extension. It's the exact opposite. Okay. So please keep in mind that the terminology has a very specific definition in movement pattern. But you'll notice on this page, what did I not talk about? Muscles. I didn't talk about anything. So where does the hamstring fit in? Well, just in this case, the actual muscle that is involved, the actual muscle that's involved with creating this kinesiological movement function at the knee is called the hamstring. Now, the muscle, one of the muscles that is involved with extension, right, to move the leg back down to this position, one of the muscles that does that, or muscle groups, excuse me, there's 3 muscles in there. One of the muscles that does that movement concentrically is called the hamstring group. It's the same group. Why? Because the hamstrings attach on the lower leg, cross over the knee, and then attach up into what's known as the pelvic tuberosity, okay, of the pelvis itself, and therefore it's 2 joints that it works over. Now, as soon as we start getting into this discussion of eccentrically decelerates, you're going to get confused. Just keep in mind, eccentric contractions don't allow flexion or extension. It depends on the muscle, and it depends on the joint they're working over. So you don't want to confuse those two. What you need to understand is that a muscle like the hamstring, when it lengthens, it is going to allow for knee extension. Listen to what I said. When the hamstring, let me go back up here. There we go. When the hamstring lengthens, when it goes from a shorter length to a longer length, what does it do? I'm just going back and forth for you. What does it do? It allows for the exact opposite of what it did when it concentrically contracted. It flexed the knee. Well, eccentrically, it's going to allow for extension of the knee. It's going to allow the knee to straighten back out. It's those terms are the exact opposite at the hip, however. Okay, and it's because the hamstrings concentrically, when they shorten, when those hamstrings shorten, they're going to tend to pull the hip back down this way. Now, when the hamstrings lengthen, right, or go through an eccentric contraction, they're going to allow for the exact opposite to occur at the hip. See, don't think that all this stuff is happening, separately and individually. It's all happening simultaneously with hip extension and knee flexion. Normally, we don't kick our leg up, as you see in this picture. Normally, what will happen is you'll see what's known as triple flexion, just as a for instance. So you have the ankle, knee, and the hip flex all simultaneously. But in this picture, it just makes sense to understand that the hamstrings, if they are lengthening under tension, what are they going to allow for? They're going to allow for hip flexion, right, and knee extension. Let that settle in a little bit. It's a good idea, to be honest with you, and I don't want to overstep my bounds of trying to clarify things, and I end up confusing you even more. Rewatch the video. Take some time, stop it, take some notes. Okay, there's some basic disciplines of study that you have to make sure you do. No matter who you're watching, no matter what you're doing, there's basic disciplines for studying. Number one is don't read and think you're studying. You're not. Okay, you got to get your disciplines in place so you can pass the darn test. Does that make sense? Don't read and think you're studying. You got to read and write and do other things. The other thing is that when you're watching videos, you're watching this video, for instance, Don't sit here and look at me like this. That's interesting, Doug. I have no idea what you're talking about. No. You have to have basic disciplines for studying. When you're watching these videos, you watch my video, whatever you're watching or listening to, pick up your pen and put the thing on pause. You can pause these videos, right? Put the thing on pause and go back and think, what the heck did he just say? Damn, I need to utilize these as a resource, not as a point of entertainment. And don't get frustrated. If you're getting frustrated when you're studying, listen to me, if you get frustrated while you're studying, you are not studying in line with the basic components of your learning style. Okay. If you're spending 3 hours studying, and then all of a sudden you look up and you go, whoa, I don't even know what just happened. And that's not the way we do it. You need to be efficient. That's what the read, write, recite methodology helps you with. Also, make sure that when you're utilizing resources, put the pause on and write. See, this is one of the things that you have to keep in mind over the years. I've been doing this a long time. One of the most effective things you can do is to write. Use paper and pen and markers. If you want to use highlighters, that's your business. Highlighters are a waste of time, in my opinion, because all you're doing is rereading. But if that works for you, good. My suggestion, though, is that if you're finding yourself crunched for time and you're inefficient in your studying, go through this again. Take notes while you're doing these videos. Anything that you see, any of our study material that we provide you at Body Design University is not meant to be a form of entertainment. It's meant to be a resource so you can study and learn the materials. Please understand, our goal is to help you pass this exam on the first attempt. If it's not your first attempt, then whatever attempt it is, you're on. And any questions that you have, please leave them in the comments. Subscribe to our channel, please, and you can go ahead and hit the bell so you can get notifications as more content comes out. You got to interact with us so we can help you. So if you have questions and you need clarification on this particular video or any video that we have out on this YouTube channel or in our Facebook group, for sure go there, because we've got a lot of folks. We've got the largest NASM Facebook group right now, study group, that you're going to find. And there's a lot of folks helping each other out. Please go and access that and just let us know if we can be of any assistance. Again, it's a pleasure, as always, to bring you this information and material. Have a great weekend, and we'll see you next week. Thanks.